Okay, so real quick, I just want to talk about some of the things or suggestions I had for the Automata project. A few of the big things, just where to find some of these resources that you're going to need. So the first part here is this Automata resource page is going to be linked on the top of every single weekly page from here on out. So you got week 12 next week and week 13 the last week. So it'll be there. There's a lot of good stuff in there, so make sure you take a look at it. Some of the big stuff, you've got your design brief. Make sure you're checking back there to make sure that your design meets the criteria that you want. The big thing on this one is that there are different levels that you can choose to work to. If you are working towards a B, and we'd like to, that's still your kind of meets the standards grade. To meet the standards, you've got to have realistic motion, which means you need to have shown me a motion graph for each item. This one, operating as designed for 1 minute, that's only for the physical model. You're not going to be doing that if you're online. Same thing with no visible slip between the components. The big thing you can look at with these two is it's got to actually work in Onshape. When you share with me, I need to be able to animate that crank, and it needs to be able to turn. The system must create repetitive motion. You'll be turning in some brainstorming. So at that point, I'll take a look at your theme and what's going on. And if I've got any questions or concerns about that, I'll be talking to you before you get too far into designing it. And it's going to use that same box that we've designed earlier. I'll show you where you can get that if you need it. If you're happy with a B, a maximum grade of an 85% a B, then it's got to include at least 3 cams with realistic motion. That means to me that it has to do more than just have the pieces going up and down. It's got to have some sort of a thought put into it that's what those objects should actually be doing to tell some sort of a story or meet the theme that's going on there. If I just see 2 objects kind of bouncing up and down randomly with you making no attempt to explain those, then that's not meeting that criteria. What I'd look for is 3 objects where you've created a motion graph to describe in words and with a graph what those objects should be doing, and then creating cams or choosing cams. You don't have to use your custom cams. You don't have to create them yourselves to do that. If you have something that you want to just kind of go up and down slowly, then that could be an eccentric cam. You already have one. You've seen what that one does. Now, if you want to go for exceeding the standards, remember an A is exceeding the standards. This is not something that I expect everybody to want to do or really have, the ability to do every single time. This is going to take extra work to get to an A. An A is not just the normal. It's got to have at least 4 cams, and one of them has to be unique. And that means that it cannot be a heart cam, a pear cam, a snail cam, or an eccentric cam. If it's only 4 you have on there are those 4, then you can't get an A on this. And so that one for sure would need some more complicated motion that you've described, and then making a cam that creates that motion. In addition to that, it's got to have at least one of the 2 following things. It could be that you have 2 cams that act on the same thing. So kind of imagine like a butterfly. You've seen one of the examples has a butterfly. I'll show you what those examples are, where the 2 wings flap up and down. Well, that's 2 cams, one for each wing, acting on an object to make it have a more complicated motion. So that could work. Or probably more interestingly, but maybe a little bit harder to do, is 2 axles connected by gears or pulleys to create motion at different rates. So this could be you have a set of cams in the back and a set of cams in the front connected by a pulley. So when you turn the front crank, the back crank moves twice as fast. And then you'd have motion there that's twice as fast as the motion on the front. And that would also allow you to get 2 rows. So if you're thinking that your idea might want 2 rows, where something in the back and something in the front, maybe think about ways you can do that. And that might meet that requirement for an A. Again, A is beyond what I expect of every student. Keep that in mind. It is perfectly fine to go with these constraints here to get that meets standards, meets the expectations grade. So for you, working prototype means the 3D model that actually works. Give yourself some time at the end of the year to troubleshoot that that model. If you're trying to put this thing together the last week of class, the last couple of days of class, you're not giving yourself that time if something isn't working right. And then documentation of your design process. That part's actually going to be due a little bit earlier. You'll see that along the way. So let's go back and take a look at other things we've got here. We've got video examples. You can take a look at those just to see what other people have done. When you actually go to start designing things, you've got a couple of other resources here. The box drawing. You've had this access to this before, but I'm putting it here again. This is the one that shows you the dimensions of the box you're using. If you haven't created it or somehow lost it, this is going to be a good place to go because that's where you're going to find out how to make the box. But hopefully you already have that and you don't need to create it again. Drawings for your different cams. This is another good place. If you would like to use one of these standard cams, they're here for you as drawings. You can use those drawings exactly as they are. You can make them any nominal diameter you want. There's no real reason to make these parametric unless you're having two different sizes and you want to make it parametric. You could just decide that you wanted this to be 3-inch diameter and just make it 3 inches. 3/4, and then your through hole. Remember the through holes on ours are going to be square, 0.255 inches square, because we're using a square crankshaft. Any of these do not count as custom cams. If you're making one of these are the standard cams that you are provided. Okay, going back here, other things that you've got access to. I wanted this one. Standardized parts. These are for your actual 3D model when you get to that. This is a link to an Onshape document. And once it loads here, you'll see what's in this. This is going to give you access to all the parts that you are going to need that I'm not requiring that you make yourself. So you've got a crank in there. You've got these different bushings. So this bushing, if you see, I'll probably put up a link to an example that I've made. These two red bushings are going to go on, put my camera, on either side of the box. So if you're looking at your box, either side of the box, your crank goes through them, and then those are what actually turns in the box, rather than your actual square crankshaft turning in the box. So you're going to need those for sure. These next group are your follower guides. You've got 3 different options. You're not going to use all of them probably. Most of you are just going to use these square follower guides. Unless you need the follower, the part that goes up and down, to be able to spin, which most of you I don't think are planning on doing that. This is probably the one to go with, a square one. That would, in real life, that would keep it from spinning. Obviously, in the 3D model, it's not going to spin unless you set it to spin. But you're probably using this one. If you want them to be able to spin, you've got some round ones. This is for a 1/4-inch round dowel. This is for an 1/8-inch round dowel. You see the hole's a little bit bigger, so it says 288 or 280. That's to give a little bit of room in real life. And then the last ones here, if you look all the way over here, nope, don't do that. Can I not have that in the corner? Anyway, if you go all the way over here, then these rollers here, you've got, again, 3 different rollers. This is a 1/4-inch round roller. This is an 1/8-inch round roller. This is a 1/4-inch square roller. They're going to match up. If you're using the 1/4-inch square roller, you're going to use the 1/4-inch guide bushing. These are what actually rides on your cams. They'll go on the end of your little follower rods, and they will make it so that there's less friction between those follower rods, and that they're nice and smooth so that they follow your cams better. Now, this is a folder here. You've also got access to pulleys. You might not use these pulleys. If you want to use multiple crankshafts, then you're going to need pulleys to connect them. I don't have the gears model. We're just going to use pulleys. And so you can see there, you've got 4 different sizes of pulleys that you can use already modeled for you. So you don't need to make those. And the last thing we got here are the assignments. You'll be doing this first one, Automata Brainstorming, and then the second one, Automata 3D Modeling. If you're in the in-person class, then you'll be doing the physical prototyping as well. So brainstorming. is the one working on first. You're going to be conducting a brainstorming session. You need to document that process. So that means you need to show me evidence that you actually considered a large quantity of ideas and that you built off of those ideas and that you then narrowed it down to what a final design is going to be. You should be writing these down. You should be drawing pictures because you need to turn in evidence that you've done this. If it's all happening in your head, then you don't have any evidence. So make sure it's happening on paper. And then you're going to be creating a detailed sketch of the design solution. This needs to include everything that you can think of at this point. It needs to include an isometric of the actual finished box, what it's going to look like with the figures on top, with the cams in it, with the push rods in it, with everything on it to show what it's going to look like. After that, you need to look at the pieces, any of the pieces that are non-standard. So the box is standard. You don't need to worry about that. The crank, the follower, the guides, those are all the standard parts that are in that Onshape file. You don't need to dimension those. But any of the other parts you do. The figures, how big are they going to be? What are you going to use to make them? Are you going to just take a picture, paste it into Onshape, and then trace it and extrude it? Are you going to actually make a three-dimensional model in Onshape of that thing? Your push rods, how long are they going to be? What type are they going to be? Dimension those. The crankshaft, it's going to be a 1/4 inch square, but how long does it need to be? If there's 2 of them, show me that. Are they the same length? All this stuff needs to be included in there. Other things that you should definitely be including are evidence that you've thought about the motion of the objects. What are the different objects going to be? What motion are they going to have? You should probably have thought about graphing that motion to be able to describe it, along with what cam's shape is going to make that motion. All of that stuff needs to be included in here in order to get completely describe what you're planning on doing. That doesn't mean that it can't change. It absolutely can change. But to really have thought this through at this brainstorming step, I need to see all of that stuff. And then as far as submitting this, it's going to want to go in a Google Doc with just all of that stuff. Evidence of your brainstorming, evidence of your decision making and narrowing it down, detailed sketches, orthographic views of the parts, dimensions, isometric view of the whole thing, detailed drawings of the cams you will use. That's going to include motion graphs, not just the cam itself, but what motion it's going to create and why. And then a written description explaining how your solution meets each of the criteria. The big one I'd be focusing on is how it's going to meet the required motion. So what motion are the objects going to have? Why is that realistic? Now, just a couple of suggestions here. My suggestion would be to first decide on a theme. What theme? What kind of characters do you want on top of your Automata box? So if you're going to make a theme that's SpongeBob, that might be your theme. Now you can decide what characters and items should you have. They don't all have to be characters. They can be other things too. Maybe one of your items in your SpongeBob thing is going to be SpongeBob flipping a burger. So one of the things is going to be the burger getting flipped up and down. How are you going to do that? Then you want to go back and think about the cams that are going to create the motion you want. If we want that burger to get flipped, maybe it's going to, if I'm thinking about the motion graph, my camera back up here, maybe I'm thinking about a motion graph, it's going to stay on the spatula for a while, it's going to go up and down, and then it's going to stay on the spatula again. Well, what shape of a cam would that be? Draw out that motion, tell me why it's doing that motion, and then tell me what cam is going to make that motion. That would be a pair cam probably. Once you've done all that, then you can actually start drawing what this is going to look like, deciding how high up everything is going to be, getting some general measurements. Again, you're probably going to change these as you see what it looks like in the model, but this is going to give you a chance to kind of get a starting point. That's the benefit of the 3D model. It lets you change things around without actually having to remake stuff, but having a starting place is going to help you out. Okay, so that's kind of been a pretty long video. But hopefully what you've seen there is enough to get you a good start. You will also have this 3D modeling of the Automata project. We will definitely be talking about that Friday, kind of getting into the start of that and what it's going to look like, what you need to do for that. So that means if you want to be staying up on this by Friday, you should have a good idea of what this is, even if it's not quite done, being really, really close to getting it turned in. And so you can kind of start to think about the 3D model on Friday. Okay, I'll see you in class or see you later.